Hey guys, Mike V from Reliable Automotive Equipment. Today we're going to be going over the carbon system. This system will do the structural aluminum studs welded onto the vehicle for ground studs. It'll do rivet removal. It'll also weld on the tabs for the dent removal system. On the carbon unit, we are going to start off with doing aluminum bits for doing dent pulling. So this is the gun unit that comes with it. A couple settings on here that we're going to go over. We have a little card here that will tell us everything that we need to know. So to get set up with for the bits, this is the first piece that's going to go on. This will slide on. It's held in place with the little Allen screws. This can rotate wherever you want, wherever it's comfortable for you to hold. Not a big deal on that. I'm just going to take the little Allen screws, snug these up. Don't over tighten them. It's just going into the plastic nose cone, just holds it in place. This is just a little spacer bar for setting up for the proper welding space of the bit itself. So we get that set. This is going to be the piece that actually holds the aluminum bit, and that is just going to slide into the gun assembly here in the front. Just push that in, bottom it out. Just take the little nut there, snug it up. Take the wrench out, just a little, not real tight, just snug. We're going to take the blue hose, plug it into the blue hose. That's for the gas coming out. So now we actually have this set up where the bit will set in here, and this will be our distance bar so that we have the correct distance on the panel. Before we go to set the bit in the gun, a couple things that we're going to do is going to turn on the machine, main power switch here in the front. We'll turn the machine on. We're going to refer to our chart here because this is going to give us all our settings for doing the welding on the vehicle, on the product that we're going to be doing. We're going to be working with a 1mm bit today. Our working material is aluminum. Our component material is aluminum. On here, we're going to have an amperage setting. So this little A that's covered there would be 130 amps. Then we have a little timer that we set. So we'll have 5 milliseconds on the timer. The gas time is going to be set up for a 1 second. Right now we have straight argon on here for a shielding gas. They do recommend a trimix, which having nitrogen and helium in the mix also. It makes the aluminum burn a little bit hotter for a better weld. Then we're going to have the gas flow. They have it listed at 10 liters per minute. 10 liters per minute does convert out to cubic feet per hour at 21. So we've gone through this in the industry for a while for liters per minute and cubic feet per hour. It's a very easy conversion rate just to find on Google. We have a gauge that is listed in cubic feet per hour, so we're going to set that at 21. It will equivalent out to 10 liters per minute. Then these last two, this lift and this resilience scale, these are going to be settings on the back of the gun that we're going to do. So this first one that says lift of 1.0, what we're going to do is take the back part of the gun here. We have a couple of knobs back here for setting the lift and the resilience. We have a little scale here. If you can see these little numbers, this scale just rotates around. There's no fixed point on this. To set this up properly, we're going to put the little 0 in line with the 0 on the label. So now that we've indexed that scale to the gun assembly correctly, we can take a look at, there's a white line on this next scale, which if we pull this back, we can turn this, and now we can line it up to the 1.0 with this scale being indexed to the gun assembly. So I'm just going to take the white line, put it over 1.0 and lock it in. And then the next one on the scale is resilience scale of 6. And you have to do these in this order to get the proper reference point. So now that I have my white line, I'm going to take the very back part. This is the resilience scale. And I'm going to line up the number 6 right over the white line. So I'm just going to go ahead and take this, eyeball that down there. This here will just spin all the way around. Number 6 over top of the white line is set on 1.0, and our scale is indexed out at 0 to 0. So we're good on our settings. So that is our very simple settings on here for setting the gun up. Now we're going to go to the front of the machine and set up our amperage and our time. So on the unit here, the first one on the bottom is the amperage. And we are reading 130 on the chart, and we are doing 130 here. And these you just use up and down arrows to change the numbers on that. The timer at 5 milliseconds is up here. The gas flow time, this is a dual system right here. So right now it'll always show the timer. If I take the gas, turn it off, and then turn it back on, it'll flash. This will flash up 1,000 milliseconds, which equals 1 second. It will hold that for about 5 seconds and then go back to the timer time. So now I'm back on my setting of 5 that I can change that anywhere that I want to change. So that's our type of material, our amperage, our timer on it. The gas time is set at 1 second. The volume of the gas is set at 10 liters per minute or 21 cubic feet per hour. The lift is set and the resilience scale is set. Now what this does, this gets you set up to start welding your tabs on. So we're going to start welding at the suggested points of starting. When we weld one tab, we're going to see how it goes, and we might have to adjust it a little bit depending on the type of material that you're going to. So we are going to grab a 1mm tab, and on all these tabs, there's a nice little index layout here on that for the different sizes. We have tabs that will have a little half twist in them, and we'll have tabs that will have a straight piece coming down, so you can line up all your tabs depending how the crease is going in there, so you can get whatever rod you want to put there or puller on it to have it come out properly. But these tabs are also marked. They're stamped in here, and it says 1/1.0. The 1.0 is the thickness of the tab. The 1 actually stands for, this is a ALSI tab, or aluminum silicone. This is a 4000 series tab. If we take a number 2 series tab, that's going to be ALMG. That's going to be aluminum magnesium, or a 5000 series. Then we have a number 3 tab, which is actually 99.5% pure aluminum. So you have different tabs that you can take depending on the type of material that you're going to be welding on. The manufacturer does recommend try the pure aluminum tab on your outer panels first. Through little experimentation, on this panel here, this is actually a 4000 series roof panel that my ALSI tab actually welds on better. So I'm going to go ahead with this. We're going to start out at those settings and see how the pieces weld on it. So the way that we set this up, gun assembly is all set. So we take the tab, it's going to slide right into this area here. So the side that is printed on should face up because it gives you better contact on the bottom for the gun assembly. So it just goes right inside of here, hits that little nylon roller, push it all the way in, and that's set to go. What this little lift bar here is going to do, if I turn it one way, it slides in and out. If I turn it the other way, it locks. Now what's going to happen in the welding process on this is that this tab is not going to weld into the panel. The problem with welding into the panel, if you pull the tab out, you have a chance of tearing out part of the panel. So what this is literally going to do is it's actually going to take this tab, pull it off the panel just a little bit. That's what that lift thing is for, about 1 millimeter. The arc is going to happen, and it's going to melt the bottom of the tab and literally glue it right onto the top of the panel. So it's not being intrusive into the panel itself. So what this bar is going to set up, when I loosen this, if I hold my gun so that this tab is just touching the panel, not pushing on it, just touching, bring that in so that touches, lock that in, and now this is going to set this up that when I pull the trigger, this will come back a little bit. This will keep the gun from going forward and to make the weld. We've got to hook up ground cables. It does come with 2. So on these, just going to clamp these on, nice clean area. The other thing that we do need to look at too is on the card, our aluminum bits are fine going across. On some of the other ones we're going to get into, there is an area where we do reverse polarity, so that you'll actually have the ground clamps actually taking the power coming in there, and then the gun itself would be grounded out. So on the bits, we are going to do standard one, where the ground actually goes into the ground on the unit, and the gun assembly is supplying the power to it. When we go into the studs, we are going to be doing reverse polarity, and that does make a difference in how it does weld on the panel. So we have the gun set up, we have the ground clamps on, we set our gun up to the hood, we make sure that this panel, the lift device here, is adjusted correctly. So we can take the bit, do a little test on it, see how it welds on. Seems to be welding on pretty good. If it does pull off, what you would end up doing, instead of bumping up amperage first, just take your timer and add another 5 milliseconds to it. Give it a little bit more time to weld. So that's the little bit of a learning curve on this when you go to weld the bits on, what works and what does not work. It should almost look like, when you look at the bit, it should look like a drop of melted aluminum on the end of the bit sitting right on top of the panel, which they are doing. So again, different thicknesses. You can increase amperage a little bit, but do up your timer a little bit first, and then you can increase amperage a little bit. That is welding the aluminum bits on. Obviously, as you'd be welding them on, you would have them in a crease area where you would have them lined up, so you can turn the bits the way that you want to line it up to put the pin through for pulling the material out. The nice part about these is that when you go to take these off, don't twist them off. Comes with a little pair of pliers on it to get in there nice and tight. Clip the panel off and then take a body file and file down what you have sitting here. Because if you go hit that with a little roll-lock disc, what you're going to do is introduce a lot of heat into that little area, and it's either going to want to come out or suck back in a little bit. So once you have it back where you want it, finish off your material cold. All right, we're going to do stud welding. And before I continue on with that, I do want to say that the instruction book that comes with this, the first part of the book is a very good history on aluminum and its source and some of the theories behind it. And then as you get into the other part of the book, it really has a lot of good information on setting up the unit, pictures of it, the different studs that are available, or the different bits, the different studs, the different composition of the materials. There's a lot of good explanation in here in the book. This video is to help get you rolling on the system. This book here will give you a lot more technical information to help you on completing the whole setup. So when we go into the stud group, we do have one up here that is steel on steel. Today we are doing aluminum on aluminum. One of the first things we do notice as we go across, we are going to be doing reverse polarity on this setup for doing the stud welding. So instead of the power going from the gun to the ground, the power is literally going to come from the ground up to the stud, and that's what helps give it a great fusion into the material. So all we're going to do is take our main gun assembly, disconnect our ground wire, put up the ground into the main gun, and then this one down into the ground, and that's it. Everything else stays the same. On setup on this, this is the little control plug for the gun assembly. This is for the gas. So when you plug in the gun assembly, plug in the little blue line. This only goes on one way. Turn it till it goes in position. Snug it up. That part is all set. So if we go into stud welding, we are going to be doing a 4mm stud, aluminum on aluminum. Our amperage is now going to ramp up to 400 amps. On the timer, we're going to be 5 milliseconds on the timer. Gas time pretty much stays the same. Gas time is going to be at 1 second. Gas flow again is going to be 10 liters per minute. Now we're going to go into when we set the stud in there for the projection of the stud sticking in. We'll get into that in a second. The lift and the resilience is the same as what we did for the aluminum bits. That pretty much stays the same throughout all the operations. So the lift is set at 1.0. The resilience scale is set at 6. What we're going to do is take a look at the gun, just verify that we didn't knock anything around on it. So again, we're going to make sure that the 0 on our scale is lined up with the 0 on the gun. Then we can check our little white mark is set up on 1.0. And then we can look at the resilience, and 6 is still over the white line. So we're good on our settings on that. But now we are going to change out this for doing the bits to what we need to do for doing the studs. So we disconnect the blue hose, reverse of what we've done, just loosen up this locking nut here. So this piece here slides out. We're going to loosen up the little Allen wrenches on this piece. So that piece there slides off. So now we have the assembly that is going to hold for these studs. This piece here will go on just like the other one did. There's no particular location on this. We're just going to put this on, snug these up, and then we're just going to hook up the blue hose. So on our setup here, these are actually going to be studs welded onto the panel, not for the purpose of dent pulling, but for the actual use of having studs on a panel, such as a ground stud or a stud that's going to hold a piece of the wiring harness or a piece of equipment on the car. These come into great play when you're replacing a floor panel and it doesn't come with studs on it. Now, instead of having to cut the old ones off and trying to MIG them back on, you can just spot weld them back on with this system. That's one of the main purposes of this system. So the different sizes that we can go on the studs is anywhere from 4 millimeter up to 10 millimeter. So that means the ground studs that are 10 millimeter, they'll weld on just fine. So we are going to be doing a 4 millimeter stud today. So in our packet selection, we have our different size studs. And these are all marked out with the numbers. I have this one out already. It's M4, so this is a 4 millimeter stud opening. When we put this stud in here, I want to make sure that the stud itself is going to be approximately, not touching, but approximately about 1 to 1.5 millimeters above the top of the nose cone. Very important for that to happen, because the way that these studs work, and this little screw is an adjusting screw that will hold that, then I can lock up that little nut. So every time I put one of those studs in, it will maintain the same height. So the importance of this is that all the power is designed to go through that little tip that's sticking in the center of the stud. If that tip is not there, this will not weld properly. If this gets turned at an angle and you catch it on the side, it will not weld properly. It's just a characteristic of the aluminum stud, the way that it welds on. If this stud is actually touching the nose piece itself, it will not weld properly. So that little bit of space right there is very critical for doing your setup. So when you install this into the gun assembly, same as putting the other piece in, just push this in till it bottoms out. We're just going to snug that up. And then we have 3 different style of nose cones, different lengths. And this one will actually cover the 4, 5, and 6 millimeter stud. A little bit bigger one will be the 8 millimeter, and then a longer one will be for the 10 millimeter. So the purpose of this is that when we install this, that we are going to have approximately a 2 millimeter projection if we ran a straight edge over the top of this nozzle assembly. So that's letting that stick out a little bit for the welding process. So when we have done this now, we have all our settings on the front of the machine. We have our projection point of 2.0. That's what that's calling for. And we are ready to weld. The nose cone assembly is going to help you to keep everything nice and straight so that you're not putting this at an angle. With that sticking out, that will push back in as you push it onto the panel. So we just push in on the panel. And there's your stud welded on. Same thing now for your settings on the machine. Whatever type of stud you're welding on, if you can grab it and it falls right off, that means you just don't have enough power for that type of material that you're using. So we would do the same thing on that. Take our timer, bump the timer up a little bit more, up to 10 or 15 milliseconds, put another stud on there and make sure that you're getting good anchoring point to this. And once again, this is not used to pull a dent out because this stud is now actually welded into the panel. And when you go to try and pull that stud out in doing dent repair, and the stud actually pulls out of the panel, you usually take a chunk of aluminum out with it. So this is basically for a stud replacement on the car itself. So now we're going to go into stud welding for rivet extraction. So on certain OEs, you're going to run into a problem on trying to push rivets out of not having accessibility to it. Some of the newer rivets are being made out of such a ultra high strength steel. They don't want you drilling them out because they're so hard to drill, and the drill bit will create a oblong opening in there. So on the manufacturers that recommend the welding, we're going to set this up for doing a stainless steel piece on the rivet head itself. You can already see one on here. And we're going to set up the gun now for that assembly on there. That is still going to be underneath these studs in the sheet, where we're going to be doing a 5 millimeter stud stainless steel onto the stainless steel rivet head. So our setting is going to be 600 amps, 30 milliseconds on time. Gas time is going to stay the same at 1 second. The volume of liters per minute is going to stay the same. The projection will be the same as when we did the other studs, a 2 millimeter projection. The lift and the resilience scale set on the back part of the gun are going to remain the same. So again, on the gun, we're just going to verify on the back. Our 0 lines up with the 0. Our little white mark lines up on 1.0. and the back part of the scale 6 is still over the white mark on it. So we're verifying that we're good on that. We still have the same front on here that we did with the studs. I just took off the short little nozzle, and now we are going to put in this is a special pin for the 5mm stud, which is going to set into here like the other one. Just snug that up. Snug that up, and then this has a little bit longer nose piece going on compared to the other one. So we're going to grab a 5mm stud. So when we put the stud in this, there was no screw adjustment on the back side of this stud holder. This is designed to go in exactly the way that it is, and that will give us the 2mm standout projection. That's already pre-engineered in the stud and the stud holder itself. Our setting on there, I've set it up to 600 on the amperage, 30 milliseconds on the time. And what we're going to do on this now is we've cleaned off the head of the rivet that's on here. Our 2 ground clamps are in place. I want to make sure that my stud assembly is going to be straight over top of the rivet. You take your time on putting it on. Make sure that you hold the gun straight in all directions. We don't have that round cone like we did before, so it's just 2 little legs sticking out to get into a tight area. And we want to make sure that we're nice and straight on it. This is going to throw a couple little sparks on it. There is a little bit more power going through this. So I'm eyeballing the center of my stud, pushing down on it till my little pieces get there. Pull straight up, your stud's in place. At this point now, you would take the extraction tool that would go over the top of this, and then that would end up pulling the stud out. And the extraction tool is part of the rivet gun assembly on the Express 800. Looks similar to the blind rivet tool with the long nose on it. Would go over right on the top. It would base out right here, and then it would just pull the stud right out and retrieve it. Okay, guys, that wraps up the carbon unit for today. For more information or questions, give us a call, visit our website. Thanks, guys. Have a great day.